Good morning, good afternoon, good evening, depending on where you join. Thanks for joining this keynote presentation. My name is Nikita Ivanov. I'm the founder and CTO of a company called GridGain Systems. In the next 15, 20 minutes, I'd like to talk to you about, uh, I would say, pretty unusual topic. We typically talk on these keynotes for the Apache community. We tend to talk about something that future-looking, especially with Ignite pre-looming. But today, I want to have an interesting look back and talk about is Apache Ignite is a Swiss Army knife of middleware. This is a sentiment that I've been hearing for a number of years at this point, and it's an interesting one to dissect and see, first of all, if it is or not. I certainly believe it is not, but I clearly understand how this sentiment came around. And what I want to basically talk today about is sort of explain quickly where it came from and how it came about, but most importantly, how I internalize it when I speak to the newcomers to the Apache Ignite or GridGain Systems customers, which intersect a lot. And I know, just to preface that, I usually talk about this in terms of the key use cases where Ignite is really good. And I have three of those that I've mentioned. And I think I will give you a bit of a structure, a mental structure, how to deal with this sentiment, and hopefully we can actually fix some of that in Ignite 3.0. So, Swiss Army knife. As a matter of fact, there's a bit of a fun trivia fact here. When I started looking at it, I actually didn't know where the Swiss Army knife came from. So I looked it up, and the whole idea of Swiss Army knife was essentially was brought up by soldiers returning from the World War II, American soldiers. And, it was very hard to pronounce the Offizier Messer German word, which is the officer's knife, which was developed by Karl Eisner in the end of 19th century in Switzerland. And so the American soldiers basically came up with the idea of Swiss Army knife, which is very descriptive and very simple. So unlike that, I think many of Apache Ignite community members don't really know the bit of a history behind GridGain and Ignite. In 2007, I started a project called GridGain. It was an open source project, and the idea behind GridGain original project back in those days, almost 15 years ago, if not more, was to bring the classic high performance computing (HPC) into the realm of new Java runtime and sort of a new development paradigms. Back in those days, it was, a very fun and very cool technology, but it's basically was gaining traction. But the older tooling was, back from early 90s, and it was very arcane and clearly not updated. So the whole idea of a GridGain to begin with was very sort of a narrow, very specific application of bringing, HPC, classic high performance computing, classic parallel computing on a massively scale clusters of computers to the modern day. And that was the idea around 2006 and 7. By 2014, over a pretty long time, the project was donated to Apache Software Foundation. We changed the license to Apache Software Foundation and incubation in ASF. It was renamed to Ignite. And by 2016, it's basically started to gain a lot of traction. And it experienced a rapid growth, as I mentioned, a lot of adoption in the last, I would say, 5 years. And with the growth in adoption comes a very prodigious feature expansion. In the last 5 to 6 years, there was a lot of development in the community. If you have, most of you would know, from a key value feature set expansion to a multiple iteration of SQL engines, transactions rework. We introduced two memory architecture in Ignite 2. We've had integration with machine learning and streaming, continuous querying, service grade, and the list goes on. Now, it's a very typical situation where a particular popular project through its rapid growth stage, acquires a lot of features. That's very natural. The more people get in, as the memory computing become progressively more adapted, and accepted in a commercial world, more and more users come in and basically we're asking for this type of functionality, and that's what's very natural. That as a community, we want to grow the project, we want to get adoption, go in the right direction, and we implemented those features. Invariably, that led, in my opinion, to settling of this Swiss Army knife analogy. Because if you compare the modern Apache Ignite to, let's say, a traditional database, if you will, the database looks very narrow and very simple to understand, right? There is a SQL interface to it. It's a data management system with a SQL interface. It's basically has relational algebra behind that, and that's it. And when you look at Apache Ignite, you met with the plethora of APIs. And APIs by themselves lend to a much broader and more applicability and flexibility, which doesn't help, at least in terms of understanding. And so when the newcomers come to the project, it's very often they basically don't know where to begin. They don't have a clear view of what is the primary use case, what is the core features, and versus something that is auxiliary. So I've been dealing with this, question and questions over the time, and I kind of developed a bit of a mental structure, mental framework to deal with this. I typically obviously listen to what people trying to use Apache Ignite for, and sometimes this can answer yes or no, it works or it doesn't. But if the questions become more general, I basically try to iterate three main use cases that I believe Apache Ignite fits like a glove. As a matter of fact, I believe for all three of them, this is the best framework that's available today, commercially or open source. And those three use cases are data cache and acceleration, data integration hub, and co-located computations. Now I'll talk about three of them. The first one is data cache and acceleration. This is your classic caching and data acceleration as you know it. It is, uncanny to me that Apache Ignite, after that many years, is, in my opinion, still the best framework of any runtime, especially for Java and .NET, but any other runtimes you can imagine in existence today. This is, the only framework that I know of that allows you to build a cache, whether it's an application level, whether it's on the cloud or edge level, or it's on a closed data source, or any of the combination of the above in any settings you like. It's also pretty interesting is that despite the fact that this is a very benign use case, right? Everybody understands that. It's interesting that it's still, I find it, routinely that people don't grasp the importance of caching. And we probably will sound a little bit, kind of cliche for many of us that are involved in the community, but I will still repeat it. That unlike 40, 50, 60 years ago, in the 50s and 60s of last century, the performance was really characterized or defined by your algorithms. Remember in those times we still were struggling with, sorting and storage algorithms and all of that classic, computer science stuff. CPUs were very slow, memory was very slow, so the algorithms were really a deal breaker when it comes to performance, of having performance or not. In today's world, most of those problems are solved. Our CPU is extremely fast, memory is extremely fast. So the only source of latency in our applications today is actually accessing external devices. And predominantly those are network and storage devices. And in our cloud-based environment, internet age, obviously network and storage are typically combined. So that's, that's like 99% of your latency of any applications is network and data access. And typically it's just data access, not essentially just data transmit for that. So if you can accelerate data access, you accelerate like 99% of latencies in your application. That's why caching, no matter how trivial and mundane it may sound, it's still basically one of the best ways to bring a top level acceleration to your application. I think it's very important to remember this simple fact. It's still probably the best way to speed up your application. And again, Apache Ignite has the best feature set for that use case. And this is the first one that I always refer to. It's very simple to understand. And again, Apache Ignite fits like a glove. There is no better software, in my opinion, for a caching implementation or whatever complexity you can have. The next use case that I talk about is Data Integration Hub. Now, before I talk about this, there's a couple of comments I'd like to make. So these use cases, I have three of those, right? The caching acceleration, data integration hub, and collocated compute. They're not completely independent use cases, right? It's very clear that most of the implementation of Apache Ignite would have some of the collocated computations in it. So those use cases are not like completely isolated. They have a lot of intersection. Moreover, some of these use cases, like for example, data integration hub, clearly relies on other use cases, like caching, for example. But nonetheless, it's a good abstraction and a mental framework to point out those use cases as the kind of primary idea holders for where Apache Ignite can be used. Now back to Integration Hub. So Integration Hub essentially is a sort of architectural approach, and it solves the following problem. There are many organizations that have a very desperate data sources, and they can be different based on formats or data velocity and update velocity, a cost structure, whether it's a local data or it's a SaaS service that you pay per query. It can differ in a life cycle and many other different characteristics. So when you want to build an app or a system that needs to query data from all these different sources, there's literally just two major approaches to that. First is the federated query engines, and there's quite a few in the market and they're pretty good. They can query all of those different data sources. The problem is that query will typically be just as slow as the slowest link. So it can solve the problem of accessing this data in some fashion, but it's definitely going to be awfully slow, because if you just have a third-party SaaS service, this is going to take often seconds for any even simplistic queries, which can be essentially a non-starter for many applications. The second approach is what I'm referring here is a data integration hub. This is the approach where you put with Apache Ignite implementation, where you put a cluster of Ignite in front of those data sources and you pre-cache or use any other policy of how this data ends up in this cluster, right? From all of these disparate different data sources. And that cluster of Ignite provides a unified API to access. It obviously does it with extreme speed, as Ignite does. It provides single lifecycle, single structure. It provides a unified code structure to that. So it basically unifies on all levels. Now, to be honest, 10 years ago, I've never heard about that integration hub, let alone 15 years ago. But in the last, I would say, 3 to 4 years, at least on the GridGain side of things, I started to hear a lot of those use cases. It's uncanny how it's rapidly gaining traction, because as companies get more and more of those desperately different data sources, they obviously need to combine data from them in one way or another, all sort of coalesce around those two different approaches. And if you need to have a high performance access to that data, there is literally no other option. Apache Ignite is a perfect middleware to build that data integration hub. So I do believe that across these three use cases, this is the one that's probably going to see the most growth in the years to come. It just makes sense overall. Now, the last one is the collocated computations. Now, this is, again, it's a classic high-performance computing, I would say, mechanism for a data-intensive use cases. The second subboard actually describes this perfectly. And again, I apologize if all of this is somewhat familiar for some of you, but it's always useful to kind of remind ourselves what are the basics of what we do here in the Apache Ignite community. So the collocated computation, the best way to actually understand what it is and why it's important as a major use case is to look historically. If you look back in late 80s, early 90s, there was a time over client-server architecture, and it's actually always extremely surprising to me that we still see systems built with that assumptions even today. I'm not talking about a system that we're trying to modernize. I'm still seeing from time to time the architecture proposals on architecture that actually employs that methodology. What was wrong with the methodology? Essentially, in a client-server architecture, the way you process data is you have to load the data from the database layer into the application layer where the logic is. Then you process this data in your application layer and then essentially discard it. And then you just play something back to the user interface. So the collocated, first of all, what's wrong with that, right? Well, I think it's obviously what's wrong with that. It worked for a very small data sets, for a data bundles that travel between database and application are small enough. In the internet age, it's inconceivable. Your data sets are humongous. Your individual data blocks can be extremely big, depending on what kind of data you're processing. So this approach just doesn't work at all. So the collocated computations essentially is reversed from the client server in this sense. Instead of moving data to the application layer, you move in computations to where the data is located. Essentially, if your data is located on multiple nodes in the cluster, and if you perform the job that requires a certain, let's say keys, right? So you move that job to a node or multiple nodes. In this way, you have a MapReduce type of, processing to where the data is located. So you're always trying to minimize, reduce to absolute minimum unnecessary data movement. This is the key for a scalable data processing, high performance data processing on a large data sets. There's just theoretically no other way of doing this. You'll find the same way on the CPU level all the way to something like Apache Ignite. It's the same idea, same paradigm. Without a doubt, Apache Ignite has a #1 industry implementation of this idea. It's been there for, I would say, almost 12, 13 years. In its current form, it's constantly been improved, and today, this is the #1 implementation of the collocated computations in the world, without a doubt. And so essentially, just to summarize, those are 3 use cases that I sort of bring up every time I sense there is a Swiss Army knife sentiment that I hear from a customer or from anybody who's talking about Apache Ignite or GridGain for that matter. And I bring those use cases as an example of where the Apache Ignite is really in a kill zone. Those are use cases where Apache Ignite is the best, not just one of the best, is the best software that's available today, both commercially or open source. So with that, I want to thank you. Please enjoy the rest of the presentations. We have a great lineup for the summit. And once again, thank you very much.
Thank you, Nikita. That was a fascinating talk. Just bring you back on. Hello again. Thank you for that. It was an interesting talk. As I say, it kind of brought us into a slightly different direction to what we normally see on kind of keynotes, but I think it's none the worse for it. So we do have a few questions. I don't see any in the chat right now, so if anyone has any questions, please do feel free to put them there now. It's not too late, but we got some in the background that we kind of saw. So the first question I have here is, what is an example of an inappropriate Swiss Army knife use case that you've seen people try to use in Ignite or GridGain for? Is there bad advice to look out for on the internet?
Yeah, I think basically we've seen this in the past, and we've actually seen this routinely, is that when people they get excited about Ignite for some reason, but they don't have a use case where performance is important. We have to remember that with all the breadth of features and some of the key use cases, the underlying reasoning behind them is performance. You have to have a performance problem. Now, we can now all kind of cavalierly say, well, what doesn't have a performance problem these days, right? Well, there are use cases where performance is not particularly a pressing issue. If you, for example, look at ad hoc analytics or kind of classic modeling, nobody cares if it's, query takes a second or two more, or, a dozen of seconds more, right? If the query itself takes, in half an hour to process, it doesn't really matter. So there are use cases where performance isn't as a pressing issue as, something like Ignite would address. So I would say that if performance is not on top of your mind, Ignite shouldn't be a default solution. It can work, but you definitely should look around and see what else can work for you as well.
So something that I've seen with the kind of engagements I've had is a certain amount of resistance to using co-located compute. Kind of people are kind of happy in a way with kind of client server, but want to get the kind of benefits of kind of co-located compute. Do you have any advice or arguments you kind of use to help persuade people to move to co-located compute?
That's an interesting one, because I guess we're going a little bit blind here in the community with Apache Ignite, because the co-located compute is not some kind of feature that Ignite developed. It's basically more like an academic axiomatic statement. If you don't co-locate one way or another with Ignite or with the different software, you theoretically cannot achieve any performance on the distributed system. That's been proven for decades by now. All that Ignite did, and the developers who developed it, is that we brought that pretty complex technical paradigm to a fairly simple API and usage and runtime. But again, in the distributed system, if you don't co-locate, the excess of networking and a data exchange will essentially kill your system. And you walk in any significant installation today, not Ignite, just generally distributed system, from Google to eBay to Netflix, you name it. I can absolutely guarantee to you that the way those big and known systems operate in exactly the same idea. They use different tooling and whatnot, but fundamental idea is the same. So yes, it may take a couple of evenings to get comfortable with the idea. It's somewhat different from a traditional client server architecture if you spend years and years on that, but it's not hard. And if you want to get down to mathematics and and all of that, yeah, it can get pretty hairy. But that's the beauty of the modern world. With the projects like Apache Ignite, you don't have to reinvent the wheel from scratch. You can get to use the benefit of this approach with the fairly, I would say, relatively simple API, where most of the hardcore concepts been implemented under the hood for you.
Sounds good. If people want to learn more about co-located compute, we do run a regular Apache Ignite Essentials training course. We're going to talk about that a little bit more later on. So last very quick question for you, Nikita, before we kind of move on. What are you most excited about for Ignite 3?
Cleanup and simplification. That's, I think, is absolutely necessary. The core technology core concepts of Ignite has been pretty much the same for the last almost 10 years. It is definitely time to, I mean, that's what we're doing Ignite 3, is to, it was definitely time to, you know, kind of stop, look back, address most of the technical debt. You know, there are some technical issues around transactions and the protocols that, you know, that needed to be addressed. I mean, this is very natural. Any project of that complexity, of that history, of that level of adoption has to go through this, or once a decade. I mean, some projects die because they just run the course, but if projects survive and grow, and Apache Ignite, you know, thankfully in that category, it must go through that stage.
Excellent. Thank you very much for your time. Appreciate it. Please hang around, enjoy the rest of the talks, and speak later. Thank you.
Absolutely.